Hi, I'm Emily from emilylearning.com. In this lesson, we will be looking at highest common factor. So, what is highest common factor? So, when we are looking at the highest common factor, we are looking at a factor that is common to two numbers, okay, and it is the highest of all the common factors. Okay, so let's take a look at this example here. So let's look at the factors of 16 and 24. So if you were to list down all the factors of 16 and 24, okay, the factors of 16 will be 1, 2, 4, 8, 16. And the factors of 24 will be 1, 2, 3, 4, 6, 8, 12, and 24. So let's circle out the factors that are common to both 16 and 24. So 1 is common to both 16 and 24. 2 is common to both of them. 4 is common to both of them. 8 is also a common factor of both 16 and 24. So if you look at the factors here, the factors that are common to both 16 and 24 are 1, 2, 4, and 8. And the largest of these common factor is 8. So we call 8 the highest common factor, or HCF, of 16 and 24. We can find the highest common factor by prime factorization. So to do so, we will first need to write the number or the composite number as a product of its prime factors, okay, in index notation. So 16 can be written in the form as 2 is to the power of 4. Okay, while 24 can be written as 2 cubed times 3. Okay, so when we are looking at common factors, okay, we want something that is common to both of them. So 2 to the power of 4 can be written as 2 times 2 times 2 times 2. While 24 is 2 cubed times 3, so it's 2 times 2 times 2 times 3. So we know that this is common. 2 times 2 times 2 is common to both 16 and 24. So therefore, the highest common factor of both 16 and 24 is 2 cubed. Okay, another way to look at it is you look at all these index notation, look for those with the same base. So both 16 and 24 have 2 to the power of something. So both, when we write them in prime factors, they both have 2 as a base, right? So 2. Then you take the smaller power, okay, or this one with the smaller index, which is 3. So you have power 3 here and power 4 here. 3 is smaller, so you take the smaller of them. So therefore, the HCF of both of them is 2 cubed, which is 8. Okay, so for common factors, right, you always take the smaller one. So first thing, it must be common. It must be common to both of them. Okay, and next you must take the smaller one, the base with the smaller power. Okay. Reason is because, right, if you were to take 2 to the power of 4 here, so when you take 24, divide by 2 to the power of 4, which is 16, you'll notice that it is not divisible, right? Because it only has 2 cubed. It's only 2 cubed times 3. It is short of a 2. It's short of a times 2 to make 16. So you end up with remainder. So therefore, for factors, you always take the smaller. Okay, or you can look at it at, right, factors are always smaller or equal to a number, right? So you must always take the smaller of them. All right. Okay, so now let's take a look at these questions here. So in the first 3 questions, you are asked to find the highest common factor of the following pairs of numbers: 45 and 72, 120 and 225, 108 and 240. I want you to do these questions by first expressing these numbers as a product of its prime numbers in index notation, and then from there find the highest common factor. For question 4 to 6, you are given 3 numbers and you are asked to find the highest common factor. I also want you to do them by first expressing each of the numbers in prime factorization. Okay, I want to express them as a product of their prime numbers in index notation, and then from there find the highest common factor. So now pause the video, okay, and try this question. Once you're done, we'll go through these questions together. Alright, so how was it? So let's do question 1 together. So in question 1, you're asked for the highest common factor of 45 and 72, and we'll start off by first writing 45 in index notation. So 45 is an odd number, so it cannot be divided by 2, so I'll start with 3 and I'll get 15, 3, 5. So 45 is equals to 3 squared times 5. Next, let's do 72. 72 is an even number. So start off with 2. So I get 36. 2 again, I get 18. 2 again, I get 9. Then I get 3 and 3. So 72 is equals to 2 cubed times 3 squared. Okay. Now that I've done this, next I need to find the HCF, or highest common factor, of 45 and 72. So first check for a base that is common to both 45 and 72, and the base that is common to both of them is 3. Okay, then we notice that both of them have the same index, which is 2, so we do not, so 2 is the smallest one. So therefore 3 squared, which is 9, is the highest common factor of 45 and 72. Next, let's move on to question 2. So to find the HCF of 120 and 225, we first need to express 120 and 225 as a product of their prime factors in index notation. So let's start off with 120. So 120 is equals to, it's an even number, so I'll divide it by 2 first. So I left with 60. Divide by 2 again, I get 30. Divide by 2, I get 15. Divide by 3. Now it's an odd number, so it can no longer be divided by 2. So I'll try 3. So when I divide by 3, I get 5. 5, 1. So in other words, 120 can be written as 2 cubed times 3 times 5. Now I'll do the same for 225. So 225, this is an odd number, it ends with 5, so I know it's divisible by 5. Okay, but it's also divisible by 3. So let's start off with 3, since 3 is smaller than 5. So I'll be left with 75, still divisible by 3. So I'll be left with 25. Now divide by 5, I get 5. Divide by 5 again, I get 1. So in other words, 225 is equals to 3 squared times 5 squared. So to find the HCF of 120 and 225, okay, I'll first look for the base, a common base. So the common base here is 3 as well as 5. Okay, next, let's take a look at the 3. So I need to take this one with the smaller index. So 3 is basically 3 to the power of 1. Okay, so I have 3 to the power 1 and 3 to the power of 2. So factors are always smaller or equal to the number. So I'll take the smaller one. So I'll take 3. Next, I have 5 and 5 squared. 5 is smaller. Power 1 is smaller. So 3 times 5 is equals to 15. Hence, the highest common factor of 120 and 225 is 3 times 5, or 15. Next, let's move on to question 3. Find the HCF of 108 and 240. So let's do it here. So I need to express 108, okay, in terms of its as a product of its prime numbers, okay, in index notation. 108 is an even number, so I'll divide by 2. Divide by 2 again. Divide by 3. I get 3, 3. So in other words, 108 can be written as 2 squared times 3 cubed. Next, I'll do the same for 240. Okay, so 240 is an even number, so I'll divide by 2. I get 120. Divide by 2, I get 60. Now I get 30. Then divide by 3, I get 5. 5 divided by 5, I get 1. So in other words, 240 can be written as 2 cubed. No, not 2 cubed, 2 to the power of 4. Because 2 is multiplied by itself for 4 times 1, 2, 3, 4. So it's 2 to the power of 4 times 3 times 5. So to find highest common factor of 108 and 240, okay, I'll first look for the base, the common base. So I have 2 as a common base and 3 as a common base. Okay, 5 is only for 240. So next, for those with the same base, I need to take the one with the smaller index. So this is 2 to the power of 2, this is 2 to the power of 4. 2 is a smaller index, so I'll take 2 square here. Next, I have 3 and 3 cubed. I'll take the one with the smaller index, so I'll take 3. So the HCF of 108 and 240 is 2 squared times 3, which is equals to 2 times 2, which is 4, times 3. So the HCF of these two numbers is 12. So now let's move on to question 4 to 6. In question 4, you're asked to find the highest common factor of 28, 63, and 180. So let's start off by writing 28, 63, and 180 as product of their prime factors in index notation. Okay, so 28 is equals to, let's do it, 2. Divide by 2, I get 14. Divide by 2 again, I get 7. 7 divided by 7, you get 1. So in other words, 28 is 2 squared times 7. Next, let's do 63. 63 is 3 squared times 7. How do I know it? Because 63 is 9 times 7. 9 is not a prime number. 9 is equals to 3 times 3, which can be written as 3 squared. So this is a fast way of doing it if you are very familiar with the numbers. If not, make use of this working here. Okay, so now let's do 180. So 180, I'll divide it by 2, I get 90. Divide by 2 again, I get 45. Divide by 3, I get 15. Divide by 3, I get 5. Divide by 5, I reach 1, so I can stop. So 180 is equals to 2 squared times 3 squared times 5. Now to find highest common factor, I need to look for a base that is common to all 3 numbers. So 2 is not common to both of them. Okay, only 180 has base 2. So here I have base 3, but this doesn't have base 3, so also cannot. Okay, so no, same. Next, 28 and 63 has base 7, but not 180. 180 has 5, but none of them have. So in other words, you notice that there are no numbers with the same base, right? So the highest common factor will be 1. All right? Okay, the highest common factor is 1 because there's nothing that is same. No other factors that are the same apart from 1. So if there are no other factors that are the same, then the highest common factor is 1 because 1 is a common factor for all numbers. All right? Okay, so next, let's move on to this 60, 75, and 125. So let's write 60 in as a product of its prime numbers. So 60 divided by 2 is 30. 30 divided by 2 is 15. 15 divided by 3 is 5. 5 divided by 5 is 1. So 60 is equals to 2 squared times 3 times 5. Next, 75, okay, is an odd number, so it cannot be divided by 2. Okay, so now I'll divide it by 3, so I get 25. 25 divided by 5, I get 5. 5 divided by 5, I get 1. So in other words, 75 is equals to 3 times 5 squared. Next, let's move on to 125. So 125 is an odd number, so cannot be divided by 2. So I'll start off with 3, but I know that if I divide by 3, I have remainder. So I move on to 5. So I get 25. 125 divided by 5, I get 25. 25 divided by 5, I get 5. 5 divided by 5, I get 1. So 125 can be written as 5 to the power of 3. Alright, so now to find the HCF or highest common factor, okay, I will look for a number, a base that is common to all of them. So 2, only 60 has base 2. Next, only 60 has 60 and 75 have base 3, 125 doesn't, so I cannot use base 3. But all three of them has base 5. Okay. Next, once I have found a base that is common to all three numbers, I will need to take the smallest index of the three. So here is 5, or in other words 5 to the power of 1. This 5 to the power of 2, 5 to the power of 3. The one with the smallest index is this 5. So the highest common factor of 60, 75 and 125 is 5. Now moving on to question 6. So in question 6, you are asked to find the highest common factor of 45, 90 and 135. So let's start off by writing 45, 90 and 30 as a product of their prime factors in index notation. So 45, okay, is an odd number, so cannot divide by 2, so I divide by 3, so I get 15. Divide by 3, I get 5. Divide by 5, I get 1. So 45 is equals to 3 squared times 5. Next, 90. 90 is an even number, so I'll start off with by dividing it by 2. Then I get 45, so 3. Divided by 3, I get 15. Then divide by 3 again, I get 5. 5, 1. So 90 is equals to 2 times 3 squared times 5. Next, I'll do 135. So it's an odd number. Okay, so I'll divide by 3. I get 45. 45. 45 is a common factor. Okay, 15. Okay, 3, 5, 5, 1. So 135 is 3 cubed times 5. Okay, next let's look at the common, now to find the highest common factor, we'll first look for common base to the three numbers. So all of them have base 3, all of them have base 5. So for base 3, I'll take the one with the smaller power or the smaller index. So you have 3 square, 3 square, 3 cubed. So square is the smallest index, so I'll take 3 square. Next, all of them have 5. So, and all of them have the same index, which is 1. So 5 times 5 to the power of 1. So the highest common factor of these three numbers are 3 squared times 5. 3 squared is basically 3 times 3. So 9 times 3 times 3 is 9. 9 times 5 is 45. So the highest common factor is 45. In fact, if you take a look at these, all these are also the factors of the number. So the factors of 45 include 45, 15, 5, 1, as well as these numbers 3 and 3 and 5. The factors of 90 include 2, 3, 3, 5, 90, 45. All these numbers are also factors of 90, but not all the factors of 90. Some of the factors of 90. All these numbers here are also the factors of 135. Some of the factors of 135. So if you look at here, actually I saw 45, 45, 45. So one look at it, you know, very likely the highest common factor is 45. And we do the prime factorization, notice that the highest common factor is 45.